Okay, this is the P1 paper from October 2023. It's question number 3. This is from chapter 1, Algebraic Expressions, and in particular, we're going to be looking at surds and we're going to be looking at rationalising denominators. Let's make a start to part A, and part A says that we have this fraction, so 8 minus root 15 all over 2 root 3 plus root 5. They've asked for it in this format here, but basically what they're saying is to rationalise the denominator, which means to get rid of the surds on the bottom here, and the way that I'm going to do that, I'm going to times by 2 root 3 minus root 5 down there, and obviously I'm hoping you've done lots of practice of this. You have to multiply by 2 root 3 minus root 5 over 2 root 3 minus root 5. So when we're doing that, then I'm going to do it very slowly, but then I'll just jump about the way through. Obviously, treat this as expanding brackets. I'm going to do 8 times that, 8 times that, and then I'm going to do root 15 times that and root 15 times that. For example, when I do root 15 times 2 root 3, when I'm doing that, I'm going to call that 2 root 45. Okay, but if you do it on the calculator wouldn't put root 45 because obviously root 45 is root 9 times 5. So that's 3 root 5. So that would give this to be 6 root 5 if we were doing all of it. I'm going to put this term just to show you what I'm doing, but then I'll simplify it without much explanation when we're going through and getting to the answer. So just to explain that before we get going then. So multiplying these out then, 8 times 2 root 3 is going to give me 16 root 3, and then 8 times minus root 5 is going to give me minus 8 root 5, and then doing the minus root 15 times 2 root 3, as I say, I'm going to say minus 2 root 45, but you might have a different value if you do it on the calculator, and then the last one I'm going to have plus the square root of 75 all over. So you might have different terms for those two. Absolutely fine, no problem at all with doing that. I'm going to use them anyway on the next step. And then multiplying out the denominator here, I'm going to take the shortcut. So it's 2 root 3 times 2 root 3. So in other words, 2 root 3 squared. And then it's going to be 2 root 3 times minus root 5, but root 5 times 2 root 3. They're going to cancel each other out. So I'm actually going to try and encourage you guys, don't put that part in. It's just going to be minus, and then these two multiplied together. So minus, in this case, root 5 squared here. So if I work out what that's going to be then, on the top, I've got 16 root 3. Let's just tidy it up. If I put them all together, I'm going to get 21 root 3, and I'm going to get 14 root 5. That's sorting out all 4 of those. And then on the bottom, for the denominator, I'm simply going to get 12 minus 5 here. So then that works out to be 21 root 3 minus 14 root 5 over 7, which obviously, I'll put that in, 21 root 3 minus 14 root 5 over 7. That's a really well worked question then, because obviously 7 can cancel in to both of those two. So I'll actually end up with, let's put it down here, equals 3 root 3 minus 2 root 5. Now you just need to make sure, I think I've got enough there, that you've got enough working, because obviously you could just do that straight away on a calculator. Sticking that in, and you won't get any marks for a final answer without all the working out that's gone in between the two. Okay, so that's part A done. Part B then says hence or otherwise, so that means hence, solve this equation. So I've already got a sort of a theory that when I'm going to go through and do this, I'm going to end up with something that involves 3 root 3 minus 2 root 5. It might be that I end up with this division here, but I'm just going to go ahead and do it like I would normally if I was given the question. So I've got x plus 5 root 3 multiplied by root 5 is equal to 40 minus 2x root 3 So all I'd do is I'd multiply out the brackets and then I'll try and get the x's all onto one side. So if I'm going to do that, I'm going to do it really slowly. I've got x root 5 plus 5 root 15 is equal to 40 minus 2x root 3. And then I'm going to get the x's onto one side, so those are going to go over there. That's going to go over there. So if I do that, I'm going to have x root 5 plus 2x root 3 is going to be equal to 40 minus 5 root 15. Factorise and take x out as a factor, which would leave me root 5 plus 2 root 3 here. That's going to be equal to 40 minus 5 root 15. And so x is going to be equal to 40 minus 5 root 15, all divided by root 5 plus 2 root 3. So now when I'm looking at that and I'm comparing it to this thing here, yeah, well, let's actually just tidy this up a little bit. This is x is equal to, if I actually took 5 out as a factor there, I'm going to get 8 minus root 15 all over. And let's just change these round, 2 root 3 plus root 5. And then this bit here, just that little bit in there, is actually what we had up here. Okay, so in other words, that yellow bit there is just equal to the 3 root 3 minus 2 root 5. So again, with all this complicated algebra, I'm really pleased at this stage that that works out to be 5 lots of, and then what we had previously, 3 root 3 minus 2 root 5 then, because then that actually works out to be 15 root 3 minus 10 root 5. And I'm pretty certain that that's going to be right then, because that worked out so neatly compared to the first part. So yeah, quite complicated. Just make sure you're practicing lots of those just to get used to them, but hopefully that will make sense to you.